Hey there, welcome to Knowledge Quest Junior, and today we're going to learn about rainbows. I'm your host. I love science and I cannot wait to share it with you. So let's get started. When I think of rainbows, I think of a colorful arc in the sky: red, orange, yellow, green, blue, indigo, violet. Can you say that 5 times fast? All the colors of the rainbow, but what actually is a rainbow? Well, to answer that question, we need to do a little experiment. Here I have a white sheet of paper and a blue and a red marker. Let's draw a little sun here in the sky, and here comes a big fat raindrop. Watch what happens when the sunlight hits the raindrop. Does the light go straight through? No, it's not that simple. Some of the light bounces inside the raindrop and then exits. And when it exits, it's not all one color. It's split into different colors. Red light bends one way, blue light another way. And when they exit the raindrop, they're all spread out, just like a prism. That's how we get our beautiful rainbow. Let's try it again. Here's our sun. Here comes our raindrop. Again, some of the light goes straight through the raindrop, but some gets bounced around inside. And when it exits, whoopee, we get a rainbow. Hey look, there's even a pot of gold at the end. But why does this happen? Why do raindrops act like prisms? Well, it has to do with the shape of the water droplet. Let's take a closer look. Here's a water droplet. When light enters the droplet, it slows down. And as it slows down, it bends. And the amount it bends depends on the color of the light. Red light bends less than violet light. And because the light is now spread out, we see all the colors. But don't forget, light can travel as waves. And when waves meet, they can interfere with each other. Sometimes the waves match up, or what we call constructive interference. And sometimes they don't, or what we call destructive interference. This happens with water waves too. Watch what happens when 2 waves meet. If they're the same size, the result wave is twice as big. That's constructive interference. If one wave is twice as big as the other, the result wave is 0. That's destructive interference. So when light enters a raindrop, it bends and then interferes with itself. And this interference pattern depends on the color of the light and the shape of the raindrop. This is why rainbows are circular. It's all about the interference of light waves. So what do you need to make a rainbow? You need water droplets in the air and a light source. And that's why we usually see rainbows in the morning or after it rains. There are lots of water droplets in the air, and the sun comes out and makes a rainbow. Can you make a rainbow indoors? Yes, you sure can. Here I have a jar of water and a laser pointer. Watch what happens when I shine the laser pointer into the jar. Do you see a rainbow? Here's one right here. Here's another. The laser pointer is our light source, and the water droplets in the jar act just like raindrops. We even get a pot of gold at the end of the rainbow. It's fun to play with rainbows, but don't ever reach for the pot of gold at the end of the rainbow. It's a mirage. It's not really there. Thanks for watching. If you liked this video, click the like button. If you want to learn more about rainbows, click the link in the description. And don't forget to subscribe so you never miss an episode of my channel. I'll see you next time.